Good morning students, Sai Ram. In today's session, let's solve the remaining problems of exercise 3.6. So question 1, problem D. 27 and 63 are the two numbers. We have to find the HCF of these two numbers. So how do we do that? First, we do the prime factorization of 27 as well as 63 to find their prime factors, and then find the common factors and multiply them. That's how we find the HCF of these two numbers. So let's do the prime factorization of 27. 27 cannot be divided by 2, the lowest prime number. So we move on to 3, the next one. 3 divides 27 9 times. 3 9s are 27. And again 9 can be divided by 3, 3 3s are 9. And 3 is a prime number, it can be divided by itself, 3 1s are 3. Till we get 1, we go on dividing the number. So what are the prime factors of the number 27? 3 into 3 into 3. Similarly, we prime factorize the number 63. 63 cannot be divided by 2, it's an odd number. So we move on to 3, the next prime number. 3 2s are 6 and 3 1s are 3, 21. 21 is again divisible by 3. So 3 7s are 21. And 7 is a prime number divisible by itself, 7 1s are 7. So how can 63 be expressed? As the product of its prime factors, it is 3 into 3 into 7. Now let's find the common factors. The common factors of 27 and 63 are 3. So we write this 3 for the common one as the common one, and then this 3 is also common, another 3. So we will take it as this and multiply both of them. 3 into 3 is 9. So what is the HCF of 27 and 63? It is 9. Now we move on to problem G. Problem E and F are a very simple one, two numbers. You have to find the HCF of the two numbers. You have to do them as your homework. Now here in problem G we have three numbers, 70, 105 and 175. We have to find the HCF of these three numbers. So what do? We do the prime factorization of these three numbers and then find the common factors and multiply them. That's how we find the HCF of these three numbers. So let's do the prime factorization of the first number, 70. 2 can divide 70 35 times, isn't it? 35 times is 70. Again 35 can be divided by 5, 5 7s are 35, and 7 can be divided by 7 itself, 1 we get. So what are the prime factors of 70? 2 into 5 into 7. And let's do the prime factorization of 105. 105 can be divided by 3. 3 3s are 9, 3 5s are 15. So 35 we get. And 35 can be divided by 5, the next prime number. 5 7s are 35. And 7 is a prime number, it is divisible by itself, 7 1s are 7. So what is the prime factorization of 105? It is 3 into 5 into 7. In the similar fashion, we do the prime factorization of 175. 175 is divisible by 5. 5 3s are 15 and 5 5s are 25. 35 we get. And 35 is divisible by 5. 5 7s are 35. And 7 is divisible by itself, 7 1s are 7. So what is the prime factorization of 175? It is 5 into 5 into 7. Now let's find the common factors of these three numbers. So what are the common factors? They are 5 and 7. So 5 into 7 is 35. So what is the HCF of these three numbers? 70, 105 and 175. It is 35. The next problem, H. We have three numbers, 91, 112 and 49. So we have to find the HCF of these three numbers. So let's do the prime factorization of these three numbers. So 91, first we prime factorize 91. 91 is divisible by 7. 7 ones are 7, 7 threes are 21, isn't it? We get 13, and 13 is a prime number, it is divisible by itself. 13 ones are 13. So what is the prime factorization of 91? It is 7 into 13. Similarly, we do the prime factorization of 112. 112 is divisible by 2. 2 5s are 10 and 2 6s are 12. So it is 56. And 56 is again divisible by 2. 2 2s are 4 and 2 8s are 16. 28 we are getting. 28 is again divisible by 2. 2 1s are 2, 2 4s are 8. 14 is again divisible by 2. 2 7s are 14. And 7 is a prime number divisible by itself. 7 ones are 7. So what is the prime factorization of 112? It is 2 into 2 into 2 into 2 into 7. Similarly, let's prime factorize 49. 49 is divisible by 7. 7 7s are 49. And 7 is divisible by itself. 7 ones are 7. So what is the prime factorization of 49? It is 7 into 7. Now let's find the prime factors, common prime factors. What are they? 7 is the common factor of all the three numbers, isn't it? So we take 7. And what is the HCF of 91, 112 and 49? It is 7. This way we find the HCF of three numbers. Now I, 18, 54 and 81. Three numbers we have. We have to find the HCF, isn't it? So let's do the prime factorization of 18. 18 is divisible by 2. 2 9s are 18. And 9 is divisible by 3. 3 3s are 9. And 3 is a prime number divisible by itself. 3 1s are 3. So what is the prime factorization of 18? It is 2 into 3 into 3. Now let's move on to the next one, 54. 54 is divisible by 2. 2 2s are 4 and 2 7s are 14. 27 we get, and 27 is divisible by 3. So 3 9s are 27. And again 9 is divisible by 3. 3 3s are 9. And 3 is divisible by itself. 3 1s are 3. So what is the prime factorization of 54? It is 2 into 3 into 3 into 3. Similarly, the prime factorization of 81 is also done. 81 is divisible by 3. 3 2s are 6 and 3 7s are 21. Again 27 is divisible by 3. 3 9s are 27. Again 9 is divisible by 3. 3 3s are 9. And 3 is divisible by itself. 3 1s are 3. So what is the prime factorization of 81? It is 3 into 3 into 3 into 3. Now let's find the common factors of these three numbers, common prime factors. So we see that 3 is common. So we put this 3 here, and another 3 is also common. Alright, for all the three numbers, 3 is a factor again. So again we take it like this and we multiply them. 3 into 3, 9. So what is the HCF of 18, 54 and 81? It is 9. Now let's move on to the next problem, J. Again we have 3 numbers, 12, 45 and 75. So let's do the prime factorization of 12. 12 is divisible by 2. 2 6 are 12 and 6 is again divisible by 2. 2 3s are 6 and 3 is divisible by itself. 3 1s are 3. So what is the prime factorization of 12? Let's write it like this, 2 into 2 into 3. Similarly, prime factorization of 43, we start by the smallest prime number. It is not divisible by 2, so we move on to the next prime number, 3. 3 1s are 3, 3 5s are 15. So it is 15. This 15 is again divisible by 3, 3 5s are 15. And 5 is the prime number divisible by itself, 5 1s are 5. So what are the prime factors of 45? They are 3 into 3 into 5. Now let's do the prime factorization of 75. 75 is divisible by 3. 3 2s are 6, 3 5s are 15. 25 we are getting. 25 is divisible by 5. 5 5s are 25. And 5 is a prime number divisible by itself, 5 1s are 5. So how can we express 75 as a product of its prime factors? It is 3 into 5 into 5. Now what are the common factors of these 3 numbers? We can see that 3 is common factor of all the 3 numbers. So we take the HCF as 3. So what is the HCF of 12, 45 and 75? It is 3. Let's move on to the next question. Question number 3. What is the HCF of 2 consecutive numbers, even numbers, 2 consecutive even numbers and 2 consecutive odd numbers? So first let's solve A. What is the HCF of 2 consecutive numbers? Consecutive numbers means continuous numbers like 2, 3, 4, 5, 9, 10, like that. They are consecutive numbers, continuous numbers. So what is the HCF of 2 consecutive numbers? We know that 2 consecutive numbers will have only 1 as the common factor. Okay, so the HCF of 2 consecutive numbers will be 1. Okay, now let's see the next one. What is the HCF of 2 consecutive even numbers? Let's for example take 22 and 24. These are 2 consecutive even numbers, isn't it? 24 is the next even number after 22. So what is their HCF? Let's write their prime factors. 22 can be written as 2 into 11 and 24 can be written as 2 into 2 into 2 into 3. So what is their common factor? The common factor is 2. So their HCF is 2. So the HCF of 2 consecutive even numbers is 2. You can take more examples of 2 consecutive even numbers and find their HCF. Okay, it will be 2. Now let's move on to the next one. See the common factors of 2 consecutive odd numbers. 2 consecutive odd numbers like 3 and 5, 7, 9, all right, 9, 11, 11, 13. We can see that the common factor of these consecutive odd numbers, 2 consecutive odd numbers, let's take for example 5 and 7. Their common factor will be 1. Okay, so their HCF will also be 1. All right, so the HCF of 2 consecutive odd numbers will be 1. Now next question, it's question number 4. HCF of co-prime numbers 4 and 15 was found as follows by factorization. So factorization of 4 and 15 is done. 4 is expressed as 2 into 2 and 15 is expressed as 3 into 5. And in the question it is asked, since there is no common factor, so their HCF will be 0. Is it right? No, because when there is no common factor, 0 is not the factor of any number, and when the two numbers don't have any common factor, they have 1 as the common factor. So the HCF of these two numbers 4 and 15 will be 1. It will not be 0. Alright. So with this problem we end this session. We will learn more concepts in the coming session. Till then, keep practicing whatever you have learnt.